these questions?
Yes, a few.
Sir, actually, I wanted to ask you something.
Yes.
Sir, our practical sessions that we are having right now, most of them, I mean, for today's practical session, our class started at 10 and it's gonna end at 1:30. So it's like we have to either attend the practical session or the maths class. So what should we do, sir? It's a
Prac-
problem for everyone here.
Practical session is should end before 1 o'clock, no?
So, but the scheduled time they said was from 10 to 1:30 in the FE division group. They said that it's gonna go on till 1:30, and I guess this is like for every day. So I'm not sure how we'll be able to manage both.
Is it for all the groups or this is a problem with one group only?
So I know that it is there for the E division, and today was Chem practical. So I'm not really sure that tomorrow, even the other subjects will have the same this thing, but that is what the problem is for today.
What is lecture schedule for other subjects? When your next lecture starts?
So the next lecture starts at 2.
So therefore this lecture should start at 1, no?
Yes, sir. So, but then we still have the practical thing going on in the other this thing. That's why, see, the number of participants are less, right now. There are only 19 people because half of them are attending the uh, practical session that's going on.
Yeah, actually, but uh, who is conducting practical sessions?
Sagar, sir.
Okay, so I will see what happens.
Okay, sir. Thank
Okay, so I have shared already one PDF on WhatsApp group. So regarding what we are going to start with in calculus 2, right? So we spent sufficient time on calculus 1, and I tried to explain each and everything that needed to be right. Still, uh, you might have some doubts, some difficulties in calculus 1, so you should go through it once again, and if you have difficulty you can ask, right? If you understood calculus 1, it will be easy to understand calculus 2, right? So and in calculus 1, what we discussed properties of real numbers, sequences and series, and we discuss almost everything, so there should not be any difficulty, right? So do you have any doubt, any suggestions?
No, sir.
Okay, so in calculus 2, what we are going to discuss basically, we discuss following points.
Excuse me, sir.
Yes.
Sir, your voice is too low.
uh, is it okay now?
No, sir. Still.
Is it audible now?
No, sir.
No, sir.
Is voice, am I audible clearly? Okay, so in calculus 2, we'll discuss the following points. And points in first topic we'll discuss limit of function. In second, we'll discuss continuity of functions. And third point will be differentiability of functions. So limit, continuity and differentiability, and you might have heard this word before in 12th standard, right? What is the limit of function? Uh, what is continuous function and what is differentiable function, right? So have you heard this word before?
Yes, sir.
Yes, sir.
Right. But then what we are going to learn if you already studied limit, continuity and differentiability? Right? That must be the question. See what we are going to learn. So what is limit x tends to 1 x plus 1? What is this limit?
2.
Okay, so limit 2. Why?
Because x is tending towards 1. So when x is equal to 1, it's the value of the function is 2.
Okay, so let f of x is equal to x plus 1, and I am defining this function on a domain. Okay, so let f be a function defined on r minus 1 to r, and f of x is equal to x plus 1, right? So the question is f defined at 1? What is the answer? Is this function defined at point 1?
No, sir.
So it is not defined at 1, right? Function is not defined at. What is the value of f1? Value of function at 1?
2.
What is the value of function at 1?
So it's not defined.
Not defined, does not exist, right? Because I have not defined this function at 1. I have defined everywhere except 1. Therefore, value of function at 1 does not exist, clearly. So, now what is limit x tends to 1 fx, right? Now what is limit?
We can say that the limit exists.
Yes, so limit exists. And what is limit?
2.
So limit x tends to 1 fx is 2, but why 2? How will you find limit and how will you decide it is 2?
So when x tends to 1, then then the fx tends to 2.
How will you prove this? How can you guess ki limit is 2? How is it possible? Yes, my question is clear.
Yes, sir.
Because whatever you learn in the 12th standard, limit x tends to 1 fx is equal to limit x tends to 1 x plus 1, and how will you evaluate this limit? 1 plus 1 and it is 2. So this was the technique which you used so far. So is it correct?
Yes, sir.
But this is wrong technique. Why it is wrong way?
Because x is tending to 1, but it is not equal to 1.
Right. Because what in this technique you just substituted x by 1 and you say that it is 2. But this doesn't make sense because f of 1 does not exist. Right? F of 1 does not exist. Since this function is simple, let us see some another function. So let f of x is equal to sin x upon x, and if I consider this for non-zero x, that means what is the domain of this function? What is domain?
r minus 0.
Right. So domain is r minus 0. So except 0, because I have mentioned here x non-zero. So except 0, everywhere it is defined, no problem. So domain is r minus 0, fine. So now the next question I would like to ask, what is limit? Which you have already studied this limit, and most of you know this limit, right? Limit is 1, fine. So limit x tends to 0 sin x upon x is 1. So why? The big question, even though you have already studied this in 12th standard. Right? Here you cannot say ki limit x tends to 0 sin x upon x is sin 0 upon 0, it is 0 upon 0. So 0 upon 0 doesn't make sense, right?
Yes, sir.
Yes, sir.
And therefore, what we are going to learn in this topic, why? Right? So what is here our aim? What is your aim? So why limit x tends to 0 sin x upon x is 1, or why limit x tends to 1 x plus 1 is 2, right? So this is our questions. Such questions we are going to answer in this case, right? This is the first thing that you should notice. And to understand this, we are going to learn a very classical definition of limit, right? And if you understood limit of sequence, then it is easy to understand limit of functions, right? Okay, so have you heard the word continuity?
Yes, sir.
Yes, sir.
Right. Now, for example, if you look at f of x is equal to x plus 1, and I define this function everywhere on R. Now, clearly this function is defined at every point. So, is f continuous at, for example, 2? Is this function continuous at 2?
Yes, sir.
Okay, yes. Then why? Why you said yes? Because there must be some reason. And what is your reason?
if we plot the graph of f of x is equal to x plus 1, we can see that it is uh, it is continuous. It does not have any breaks in the middle. So when we check the value for f of x at x is equal to 2, we can see that there is the line is continuous from there.
Yeah. So this is a graph of fx is equal to x plus 1. And you take any point, you can sketch the graph without break, right? And the graph is continuous, so that means we can sketch the graph without break. So certainly it is continuous, but and this is your usual understanding, or do you have any other way to say this? Yes. So everybody agree with this? Ki graph, we can draw the graph without break or without lifting the pencil. Do you agree?
Yes, sir.
Fine. Now I am going to define a new function on set A. So define f from A to R by, so fx is equal to x, and fx is equal to 2 minus x if x is in 3 to 10. Okay, now do you see what I have written? Can you see?
Yes, sir.
Yes, sir.
Now, what is the domain of my function in this case?
A.
So A means what? 0 to 1, union with 3 to 10, right? This is the domain. So, now can you sketch the graph? Yes. Right, this is my domain. Now, if x is in between 0 and 1, my function graph is f of x is equal to x. Correct? And if my function is, if x is in between 3 to 10, it is 2 minus x. So, what is the graph of 2 minus x? That means at 3 it is minus 1. Yes. At 3 it is minus 1. And at 10, it is minus 8. It is straight line graph, so minus 8. And how will be the graph?
Downward.
Right. Okay, so the red color segments forms graph of this function. Now my question is f continuous at point 1, right? Is f continuous at half? Third question, is f continuous at, is f continuous at 1.5? Okay, now see these questions and what is your answer? Is f continuous at 1?
No, sir.
Okay, so you said no, or most of you might have the same answer no, but my answer is yes. And then question arises, why? Right? Now, is f continuous at half?
Yes.
So answer is yes. Is f continuous at 1.5? At 1.5? No? Yes?
Yes, sir.
Right. So no, it is not continuous at 1.5. Fine. But why it is continuous at 1? Even we cannot draw the graph and so on. And therefore, we will try to answer such questions. Right? And therefore, it is different from whatever is your usual perception. Right? So what is a domain? Domain is 0 to 1, 3 to 10. And 1 to 3 is not in our domain. Right? And therefore, what is your definition of continuity? What is your definition of continuity?
Function is said to be continuous if you can draw its graph without lifting the pen.
Okay, but here we cannot draw the graph without lifting the pen. Still, it is continuous at 1. Okay, so that is again different thing. But what is the mathematical definition you know for continuity? What is, okay, let me ask. I am not making definition of continuity. I am asking what is your definition, right? What is your definition of continuity? What is your definition of continuity?
So if the right hand limit and left hand limit are equal, then the function is continuous at that point.
Oh, okay. So first definition, if limit x tends to a, fx is equal to limit x tends to b, x tends to a from right side of fx, then f is continuous at a. So let us check whether this is correct or not. So for example, I will define function, uh, define f from R to R as f of x is equal to, I will define simple function if x greater than 0 is equal to x, if x is less than 0 and is equal to 100 if x is equal to 0. Is it defined everywhere on real line? Is it defined at every real number?
Yes, sir.
Okay, now can you sketch the graph? Yes. Okay, there is a small gap at 0. At 0, what is the value? 100. Right? But if x is greater than 0, what is function f of x is equal to x? And if x is negative, then also it is same as f of x is equal to x. So there is a small cut. Do you see this? There is a small cut at,
Yes, sir.
right. Is it a continuous? My question is what is limit x tends to 0? Right hand limit at, what is right hand limit?
0 x
Right hand limit. I am asking right hand limit.
0.
0.
0
Because when I approach to 0 from right hand side, function reaches to 0. Okay. What is left hand limit?
0.
0
0. So here right hand limit and left hand limits are equal. Still function, the graph is not continuous. Do you see this?
Yes, sir.
right? But f is not continuous.
Continuous.
So what is the problem now? Therefore, the definition that told by who told Vedangi? No, who told this definition? Aditi.
Yes,
Yes,
sir.
right. Therefore, do you understand this definition is not perfect now?
Yes, sir.
Well, uh, therefore, we have to define the continuity in proper way, more technically correct. Right? This is our aim. Fine. Okay, let us look at this. A is equal to 1, 2, 3. Right? 3 element set. Now, and suppose I define f from this set A, and f of x is equal to x plus 5. Suppose I define this function. That means what is f of 1? 6. F of 2.
6.
F of 2 is
7.
7. F3 is 8, and so on. Now there are questions. Can you find limit of f at 1? Right? Can you find limit of function at 1? Or what is limit at 1? What is limit?
6.
So limit is 6 is not correct. Limit of this function at 1, because see, the simple observation, I am telling you very simple way ki look at this set. What is our set? How many elements are in this set A?
3.
Only 3. 1, 2, 3. Outside 1, outside 2, outside, we don't know anything. It is a vacuum. Vacuum. And therefore, when I say x approaches 1, then how x approaches 1? Is there any way to approach 1?
No, sir.
No way, right? And therefore, we cannot find limit at such point. So, in fact, limit does not exist. And why? So that is a question, and that question we are going to answer in this course, right? But if you look at same thing is for 2 and 3. Suppose my set is 0 to 1, interval 0 to 1, and I define a function. So I will define a function. So define f on A. So what is fx is equal to take any function x square plus 3. Right. Now my question is, what is limit? X tends to 0 fx. What is limit? X tends to 0.
3.
3.
Okay, limit is 3. But here, what is left hand limit?
So it doesn't
0 minus.
exist.
Right. So there is no question about left hand limit, because our domain of function is 0 to 1, and outside 0 to 1 we don't know anything. We should not worry, because we don't bother our outside our planet, our universe, right? anything on left side of 0 is not in our universe, is not in the universe of this function, and therefore we don't bother about what is outside our universe, right? Whatever we do in our day-to-day life is according to what exists in this universe, and therefore there is no question about right left hand limit. Only we should worry about right hand limit at this point, right? So, and therefore we should not worry about, same thing is for 1, so only and therefore in this case we should worry only about right hand limit, not left hand limit. So why limit at 1 does not exist if we have the set like this, and what is the difference between so a is equal to 1 2 3, b is equal to 0 1, interval 0 1, and I define a function from a to r, f of x is equal to x square plus 5, and I define g function from b to r, g of x is equal to x square plus 5, right? So limit x tends to 1, f of x does not exist, but limit x tends to 1, g of x is 6. So whatever I have written is correct.
Yes, sir.
So what is the difference between 1 which is present in set A and what is the difference between 1 which is present in set B?
For set B, we know the values of f of x from 0 to 1. Like any number in between 0 and 1, we know the value.
Between 1 in A and 1 in B. Right. And the difference is in set A 1, 2, 3 and in set B 0 to 1. So what is the problem? In A, function is defined at 1, but it is not defined near 1. Do you understand?
Yes, sir.
But in set B, function is defined at near 1, even it is not defined at 1. Right?
Excuse me, sir.
Yes.
Sir, in the finite sets like A, we have taken 1, 2, and 3. Does the limit never exist
Yes,
in any case?
we'll discuss these questions later on, because but why such problem arise? So limit does not exist for such set. That is true. Whatever is the function, no matter, right? Limit does not
Yes.
exist for such discrete set. And what is the problem? Ki in this set, function is not defined near 1 or near 2 or near 3. Near means what? And in set B, function is defined near 1. Yes.
Yes, sir.
And near. So what is the meaning of near? Mathematical meaning of near. Right? What is the mathematical meaning of near? So near is our day-to-day life word, and in mathematically what is it? Neighborhood. So have you heard this word neighborhood?
Yes, sir.
Yes, sir.
Right. And what is the significance of function defined in the neighborhood? Because if function is defined at near 1, then there is a way, there is a path, so that we can approach that point. Yes. Do you understand what I am saying?
Yes, sir.
Yes, sir.
Right? But when we talk about this in case of A, there is no path, there is no way so that we can approach 1, right? So, how to characterize such sets or such points, how to distinguish mathematically, how to write down mathematically or most sophisticated manner कि this point is not in near that point function is not defined or near that point function is defined, right? So in case A, one is isolated. Do you understand isolated point?
Yes, sir.
And in case B, one is not isolated. Right? Isolated and not isolated. So how to understand these words isolated and not isolated, and that's why I shared a PDF yesterday ki to understand these things you should understand mathematically what is the meaning by isolated and what is the meaning by not isolated. Right. So where in day-to-day life where do you see such kind of things isolated and non-isolated things? For example, you go in some event or some party and some celebrity come in that party. Some celebrity is present, right? So then near that celebrity, that person P, there is a crowd of people. Do you understand? There is a crowd of people near that person, correct? What does it mean? If you draw any neighborhood around that person, you can find many people from the party. Do you understand?
Yes, sir.
Yes. But if some person Q is sitting inside at some corner of hall, right? This is isolated person. Is sitting at a corner. Then you draw any neighborhood around that point. Do you find any person from party other than himself?
No, sir.
No.
No. Right. And that is what happening here. In case of set A, you draw any neighborhood around this. There is no any other element of the set. But if you look at interval 0, 1, you draw any neighborhood around 1, you can find many elements from set B. Yes?
Yes, sir.
Yes, sir.
Okay, now we want to write down all these things in mathematical way. And so do you understand this difference between this set A and this set B affect the existence of limit or concept of limit, right? So, this set A and set B, this important characteristic, important property affects the limit, concept of limit. Okay, so let A belongs to R, right? So what is the delta neighborhood? Suppose delta is some positive number. So what is the delta neighborhood of A? Is denoted by N delta A or V delta A, and is defined as, how we define delta neighborhood, because in calculus 1 also we discussed the neighborhood, right? How to define delta neighborhood of a point. So V delta A or N delta, just notation. What is it? Those elements from real numbers for whose distance of these numbers from A is less than delta, right? Do you
Yes, sir.
understand this? So X belongs to R such that, but this inequality minor delta less than X minus A less than delta, it is same, right? Those real numbers for which I will just simplify this. I am just simplifying and see uh, how it looks. So a minor delta less than x less than a plus delta. But what is the set of real numbers which are in between a minor delta to a plus delta? What is the set? Right? We denote this by this notation. So a is here, a minus delta, a plus delta, and you know that this distance is delta, this distance is delta, and if you choose any x in this between a minus delta to a plus delta, its distance from is certainly less than delta. Correct? So this is delta neighborhood. Fine. Now also we saw deleted delta neighborhood of A, deleted delta neighborhood of A. So it is denoted by deleted delta neighborhood of A is denoted by V dash delta A. Dash means deleted, center is deleted, and is, so V dash delta A is same thing, set of all real numbers whose distance from A is less than delta but other than A. Do you understand the difference between V delta A and V delta dash A? What is the
Yes,
difference?
sir.
So x belongs to R for which 0 less than x minus A is less than delta, because distance between x and a is less than delta means it can be 0, and therefore x is equal to a, but we don't want x is equal to a in this set, so distance should be greater than 0, and therefore can you see what is this set? What is this set?
So A minus delta to A plus delta minus 0.
Right, so a plus delta except a is deleted except a, so a is removed, a minor delta to a plus delta everything except a, and so how will you write this set? A minor delta to a union a to a plus delta, a minor delta to a is not included, and start immediately after a to a plus delta. So this is what deleted delta neighborhood. So is this clear?
Yes, sir.
Fine. Okay, so once you understand this, so I have already shared with you PDF, so try to answer those questions. Now, let a is equal to 0, 1, right? So, now find half neighborhood of, find half neighborhood of 1. Can you find half neighborhood of 1? Yes. V half 1. What is it? In R. So in R find half neighborhood. So what is it? X such that distance of x from 1 is less than half. Right? Is it clear?
Yes, sir.
Okay. Now what is this set x such that minus half less than x minus 1 is less than half? So this is set of those points such that uh, half less than x less than 3 by 2. Fine. This is half neighborhood. Okay, up to this everything is clear. I have 1 here and this is half neighborhood. So 1 minus half, 1 plus half. So this is half neighborhood. Fine. So therefore it is half to 3 by 2. Fine. Now my second question is, what is V have one intersection with A? Now question is clear.
Yes, sir.
Huh. Now can you tell me what is the intersection of this with the set
It
0?
is half to 1.
Right? So what is a common part? So 0 to 1 and half. Half 1 minus half means half. And 1 plus 1 by 3 means 3 by 2. So half to 3 by 2, what is a common part? So this is a common part. Right? So therefore it is half to 1. This is a intersection and it is certainly non-empty. Okay, now my question is V 1 by 100 1 intersection A, is it empty?
No, sir.
So certainly it is non-empty. Right. So now my next question is V delta half intersection with A for any delta. Is it empty?
No, sir.
Non-empty. Correct? Whatever is delta you take and look at delta neighborhood of 1 and intersection with 0, it is certainly non-empty. Right? Okay, fine. 5. So V delta half intersection with A for any delta. Is it empty? Now I am looking at half. I have changed my point half. What I am talking about now? 0, 1, half. If I choose some delta neighborhood around half and its intersection with 0, 1 interval, is it empty or non-empty?
No, sir.
Non-empty.
No,
Non-empty.
no.
Very good. Okay. 6. Now what is the set? What is the set B? Okay, what is the set B is equal to Y belongs to R such that V delta Y intersection with 0, 1 is non-empty for any delta, right? Now my question is, what is the set of points? What is the set of points for which you any neighborhood around that point, its intersection with interval 0, 1 is non-empty for any delta. Okay, so is half belongs to B? Now I will ask simple question. Is half belongs to B?
Yes, sir.
Yes. Okay. Is 1 belongs to B?
Yes, sir.
Yes, very good. Is 0 belongs to B? Yes,
Yes, sir.
because you draw any neighborhood around 0, its intersection with interval 0, 1 is non-empty, right? So is 1 by 20, 21 belongs to B?
Yes, sir.
Yes, sir.
Yes, very good, because 1 is here, 0 is here, and 1 upon 20, 21 is a very small number, but it is on the right side of 0. Certainly there is a space between 0 and this, and you draw any neighborhood around this point, it overlaps with set A, interval 0, 1. Now can you tell me what is the set B exactly? Okay, now let me ask one more question. Is is 2 belongs to B?
No, sir.
No.
Oh, very good. Because 0, 1 and 2. I have some delta neighborhood around 2 which is not overlapping with 0, 1, because this should happen for every delta. Certainly 2 is not in B. Okay. Now let me ask one more question. Is 1.5 belongs to B?
No, sir.
No, sir.
No. Very good. So is 1.0001 belongs to B?
No, sir.
No. Right. So is minus 0.0001 belongs to B. Where is minus 0.00001? It is very close to 0 on left side, right? And I can have some neighborhood which is not overlapping with. So what is my set B? Ki for every delta this should be overlapping, right? What is my set? Those collection of those points for which you choose any delta and draw neighborhood, it should overlap with. If it fails for one delta, then that point is not in B. So, and therefore, can we tell me precisely what is B? Can you tell me precisely what is B?
0 to 1.
Right, everything from 0 to 1, including 0 and 1. Right?
Yes, sir.
Okay. Now, I will do same thing for A is equal to 1, 2, 3. Now, I would like to ask a questions. Question 1. So, what is intersection V half 1 intersection with A? What is it?
Half to 1.
1.
Sir, it is half to 3 by 2.
No. What is A?
3.
Okay, what is my neighborhood? This is my V half 1, right? V half 1. What is common with set A? Intersection. So what is the common with set A?
1 to 1 by 2.
No, because this part is not common. Is right side of 1 is in set A? Is,
Sir.
le is left side of 1 is in set A?
No.
No. A contains only 1, not near 1, not nearby points. Right? Set A contains 1, not nearby points. Set A contains 2, not nearby points. So what is the overlapping thing? Only 1. Yes.
Yes,
Yes,
sir.
sir.
What is V 1 by 100 intersection with A?
1.
Again 1. So what is V 1 1 intersection with A?
1 and 2.
No, 2 is not in.
So
Oh,
only one.
again only one, right? Because when I say 1, 2, and when I say V11 means V11. So the radius of neighborhood is 1, but 1 is not included, right? 1 is not included in V11. Even it is in A, but it is not in 1 V11. So fine. What is V21?
1, 2.
So in this case 2 is also included. Fine. Now can I say that V delta 1 intersection with A is non-empty for
Yes, sir.
any delta, right? So now what is V delta half V V dash? Now I am talking about V dash.
So it's empty.
It is empty because what is delta? That is my question is there anything common which is in half neighborhood of 1 and A other than 1,
No,
right?
sir.
No, so this is empty. So V dash of 1 by 100 1 with A is empty, correct? Yes.
Yes, sir.
But in the previous problem or previous case, uh, what was my okay, let us see this previous case. V half dash 1 intersection with A. Is it empty?
Yes, sir.
No. Previous example, interval 0 to 1, half, and I am looking at okay, I am looking at neighborhood of 1, and I am neglecting 1. Still it overlaps. Do you see this?
Yes, sir.
Yes, sir.
Right. So that is a difference now. Even we neglect the point half. If you look at deleted neighborhood of radius half, if you neglect point 1, basically, still it overlaps with set A. Right. So V half 1 intersection is non-empty, and V half dash 1 intersection is also non-empty. But in this case, V half dash 1 intersection is empty, right? Okay, so you try to see this once again and try to answer the questions I told you yesterday. Try to think about those questions so that tomorrow we are going to define a very interesting thing, new thing, so that you can understand the concept of limit. All right, so is it clear? Any doubt? Yes.